Hello everyone, welcome to the channel. In this video, we're gonna focus on land subsidence analysis using Global Land Subsidence dataset in Google Earth Engine. Now let's get started. Land subsidence analysis. Land subsidence refers to the gradual or sudden sinking of Earth's surface due to the natural or anthropogenic activities. It significantly impacts the urban infrastructure, water resources, ecosystem, and human safety. The phenomenon is often associated with the groundwater extraction, mining, and natural compaction of sediments and tectonic activities, and even the karst related sinkholes. As the urban area expands, the subsidence becomes a critical issue, posing a risk to building, transportation networks, and water system. Globally, the land subsidence affects the millions of people, especially in densely populated and agriculturally dependent regions. Notably, cases include a city like Jakarta, Bangkok, and Mexico City, where excessive groundwater pumping has led to the significant subsidence rate. The coastal regions are particularly vulnerable as the subsidence exhibits the sea level rise, increasing risk for flooding and storm surges in the areas prone to subsidence. The mitigation strategies are essential for sustainable development and disaster risk reduction. The drivers of land subsidence. The primary cause of land subsidence can be categorized into natural and human factors. The natural factors, which includes tectonic movements, faulting, and natural compaction of sediments over time, and karst process due to the dissolution of soluble rocks like limestone, and the anthropogenic factors, the over extraction of groundwater for agricultural, industrial, or urban uses, and mining activities, particularly the underground coal or mineral mining, and oil and gas extraction causing a volume loss in subsurface reservoir, and last, the urbanization leading to increased load and alteration of natural drainage pattern. And this particular the global land subsidence data source is offered by the awesome GEE community catalog. This particular website which offers the global land subsidence mapping dataset. You can go through this data. Link to this particular website I'll be given in the description. You can go through this particular dataset. The global land subsidence dataset is a pioneering effort in categorizing the complex interplay between the groundwater dynamics, land subsidence, and aquifer storage loss. By leveraging machine learning and comprehensive dataset, this study contributes to a deeper understanding of environmental challenge posed by an excessive groundwater pumping and highlight the need for a proactive measure to safeguard the water resource and mitigate the land subsidence impact, particularly in a region facing the water scarcity and population growth. You can read the complete info about this particular dataset. You can click this option called full paper here. You can go through this particular paper, which gives us a global land subsidence mapping. You can also cite this particular dataset using this citation. You can just copy this and you can cite this. To access this particular dataset, we're going to use this particular code here. We're going to use this variable called variable subsidence prediction probability equals to earthengine.image. We're going to use this particular code to access this dataset. This is a license. Now let me get back to Earth Engine. And this particular dataset is a global data. You can use it for all around the world. As you can see here, we have two different kinds of data here. One is a variable subsidence prediction probability, and the second is a variable subsidence predicted recorded. That is a prediction recorded. The first dataset is the subsidence land subsidence prediction probability, and the second dataset is the recorded land subsidence. First, we're gonna use this subsidence probability prediction probability, and later we're gonna classify the land subsidence using this subsidence prediction recorded. To start with, first we have to define our region of interest. To define a region of interest, we're gonna use this HydroSHEDS basin. Level 5 dataset in order to we're gonna select a specific basin, and we're gonna visualize the subsidence rate for that particular study region. To do that, we are using this particular dataset called the HydroSHED basin level 5. So the dataset availability is from 2000 to 2000, and the dataset provider is WWF. And using this particular code, you can able to access this particular dataset. So this particular is a mapping product that provides hydrographic information for the regional and global scale application in consistent format. It offers a suite of georeferenced dataset such as the vector and raster at various scales, including the river network, watershed boundaries, drainage directions, and flow accumulation. So HydroSHED is based on the elevation data obtained from 2000 by NASA Shuttle Radar Topography Mission (SRTM). So using this particular dataset, we're going to delineate our study region. So first we have to define our region of interest. So for that, I'm gonna load this particular HydroSHED layer. So I'm gonna select my study region. So to delineate our study region, first we're gonna load our Global Subsidence Probability dataset. So to do that, we're gonna define this variable called subsidence probability equals to earthengine.image, and we're gonna paste this particular code in order to access this particular global land subsidence dataset. So we're gonna copy and paste this particular code here. So once you copied it, we're gonna paste it here. So I have already pasted here. Gonna paste this particular code to access the dataset. So now to add this layer, that is global land subsidence data, and we're gonna visualize it. So to do that, we define this map.add layer, subsidence probability, referring to this particular variable, and we're gonna set the color palettes for this particular layer. So for that, we define the palette white, starting with the least subsidence to the most subsidence. So the least subsidence being highlighted in white, and the highest level of subsidence will be indicated in black, and the intermediate colors, intermediate subsidence will be indicated in orange and red. And we're gonna output the layer name as global subsidence probability. So once you did that, we're gonna click this option called run, and we're gonna visualize it. So in the layer section, make sure that turn on this global subsidence probability, and we're gonna visualize this. So this is the global land subsidence dataset. So the black portion, which indicates the highest level of land subsidence. So this is a single image for the whole of the world, prepared based on the data available from 2013 to 2019, which is indicated here. So you can able to see that. So once this layer has loaded up, you can able to see the color palette, which shows the probability of the land subsidence, starting with white to black. So you can able to visualize here. So towards the northern portion of the northern side, which indicates the white, which indicates the land subsidence rate is comparatively very low. In case towards the southern part here, for example, this particular country, that is China. Here you can able to visualize the black, which indicates the high land subsidence, which is indicated in the black color, and the color tone, which is indicated here, the red, brown, and black, which indicates the probability of the land subsidence. So it gets higher and higher. So for example, the red and black region, the probability of land subsidence is higher than the yellow and white regions. So for example, here you can able to visualize here. So towards the in this particular study region, you can able to visualize here. So red, which indicates the higher land subsidence, you can able to see here. So you can also see in India. So in the northeastern portion of India, you can able to see that. So all the red and orange, which indicates the higher land subsidence, so which is situated in this particular the northeastern part of India here. And similarly towards the western part, you can also observe in this particular state called Gujarat. So you can able to visualize it. And similarly towards the eastern section in the China, you can able to observe in this particular study area, there is very high level of land subsidence has been observed, which is clearly indicated in darker in black color, and also in this area too. So now we're going to actually make a land subsidence layer for this particular study region. So I'm going to use the HydroSHED dataset in order to select the basin for this particular study region. And I'm going to make a land subsidence layer. So for my region of interest. So now to delineate your study region using HydroSHED basin boundary. First, we're going to load the HydroSHED basin boundary into Earth Engine, and we're going to filter based on our region of interest. So I'm going to define this variable called HydroSHED basin equals to earthengine.feature collection HydroSHED version 1 basin high base 5. So using this particular dataset, I'm going to select my region of interest using this particular data. So next I'm gonna add this map.add layer HydroSHED with the default visualization parameter and output as a HydroSHED basin. So once you have run this code, I'm gonna navigate to this option called layers, and in that I'm gonna click as HydroSHED basins. So now here you can able to visualize this HydroSHED basin. So here I'm gonna select this particular basin. So to do that, I'm gonna place this click this option called add a marker, and we're gonna click this option called, and we're gonna click on this basin in order to place a marker just like this. And once you did that, I'm gonna click this option called exceed and navigate this option here, show the generated code, and I'm gonna copy my latitude and longitude of this particular point data, and I'm gonna copy it and paste it here in your variable subsidence point. So using this particular point, we're gonna clip out this particular basin, so to create our region of interest. So next we're gonna select that particular basin and filter it based on our point data. So that is our latitude, this particular data. So for that we define this variable called basin boundary equals to earthengine.feature collection referring to our HydroSHED basin dataset, and we're gonna filter it based on the point data. That is this is our point data. So dot filter bounds point geometry referring to this particular point. So this is our point geometry, so which containing our latitude and longitude of this particular point, and using that we're gonna filter that particular basin. So dot map function basin. So in order to simplify the geometry to reduce the complexity of this particular for this particular process, I have defined return base dot simplify 1000. So next, to add this basin, we defined map.center object basin boundary, and we're gonna to add this layer we define map.add layer basin boundary with the default visualization parameter and output the layer name as basin boundaries. So now we can able to visualize the study region here. So I'm gonna turn on this basin boundary and turn off the HydroSHED basin. So you can able to visualize we have managed to clip out this particular study region. So in our next step, we're going to clip the subsidence probability dataset based on a region of interest. So we're going to clip this particular dataset using our region of interest. So this is our region of interest, our basin boundary. So to clip the subsidence probability dataset based on our basin boundary, so we're going to define this variable called clipped subsidence probability equals to the subsidence probability referring to this particular dataset. So subsidence probability referring to this dataset, this particular source dataset, and in that we're going to clip based on our region of interest, that is our basin boundary. So to do that we define clip basin boundaries. So basin boundaries referring to this particular study region, this particular basin. And to add this layer, we defined map.add layer clipped subsidence probability, and we are adding a color palettes for this particular visualization parameter. So in order to visualize this particular in different colors or the different subsidence classification, so we are adding this different set of colors as a color palette, starting with white, yellow, orange, red, brown, and black. So the lowest level of subsidence to a very high level of subsidence, which is indicated in black, and output the layer name as clipped subsidence probability. So now to visualize the clipped subsidence probability, we're going to navigate to this layer and going to turn off other basin boundaries and global subsidence probability. I'm going to turn on the clipped subsidence probability here. So now here you can able to visualize this. So let me turn on this basin boundary. So you can able to visualize this is our region of interest. So the red, brown and black which indicates the very high subsidence, and the white yellow which indicates the low subsidence. So all this yellow, orange and red region which indicates the agricultural centers because of the high volume of extraction of the groundwater reserves. So for various agricultural activities, so which might have caused such kind of subsidence. So in this particular study region, so we're gonna turn on the satellite mode here, and I'm gonna navigate to this particular area, so which is indicated in the dark color here. So you can able to visualize the color which is indicated in red, brown and black. So I'm gonna navigate to the zoom to this particular study region. So now let me turn on this basin boundary, and I will turn off this clipped subsidence. So you can able to visualize here, these are the agricultural areas with a high level of urban activities, urban constructions are you can able to observe here. So in these areas, you can able to see here a lot of build-up areas, so which can cause significant extraction of groundwater reserve, which causes the high level of land subsidence. So we're going to turn on this clipped subsidence probability and the basin boundary. And there is a lot of reasons why the land subsidence might happen. So I have mentioned only two reasons. One is of agricultural activities, and the second is the urban growth. And next we're gonna focus on our second data set here. So that is the subsidence prediction recorded. So this particular data set called variable subsidence prediction recorded. So that shows you how much the land subsidence occurred based on the centimeters from 1 centimeter to 10 centimeter or the different threshold here. So I'm gonna navigate to the Earth Engine. So I'm gonna copy this particular data set, and I'm gonna navigate to the Earth Engine back here. So here I have already mentioned that particular data set here. So to access that particular dataset, we define this variable called subsidence classification equals to earthengine.image. So this is a final subsidence prediction recorded. So the first layer, which is probability of land subsidence, and the second layer, so that is our second layer, which indicates the land subsidence. So you can go through this dataset completely here. So now to add this layer into Earth Engine and to visualize this layer, we define map.addLayer, the subsidence classification dot update mask, a subsidence classification. So the previous data which shows us the probability of land subsidence in different colors, we have observed in the probability of land subsidence which indicated in different colors. So this particular data which indicates the land subsidence which have occurred, which is indicated in this different classes starting from white to black. So these different classes which shows us how much the land subsidence have occurred. So we define dot not equals to 1 here. So next I've mentioned as the color palette. In order to visualize it in different colors, we define this set of color palettes, and output the layer name as a global subsidence classification. So now we can able to visualize it. So once you click this option called run, so we're gonna navigate to this layer, and gonna turn off this clipped subsidence probability, and I'm gonna turn on this particular global subsidence classification. So now you can able to visualize a region that is seriously suffering from land subsidence, which is clearly highlighted in black color. Let me turn to a map mode. So you can able to visualize it from here. The black color here, which indicates the high level of land subsidence. So let me turn change the color. So I'm gonna change this particular color to let me select stretch 90. So unit for this particular dataset is centimeter. So the land subsidence ranges from 1.81 centimeters to 8.3 centimeters of land subsidence have occurred. So we can able to visualize the black color, which indicates the high level of land subsidence. So let me change the color of this particular so let me add a pink color to it, so in order to visualize it more clearly, and I'm gonna click apply. So we can able to visualize from here. So high level of land subsidence being occurred in China here. You can able to visualize it. All the pink which indicates the high level of land subsidence, and similarly in Shanghai you can able to visualize the red which indicates the this particular class, so which also were closest to a high level of subsidence. So the pink which indicates a very high level of land subsidence. Likewise, you can visualize it globally. And also in India, you can able to visualize. So this particular, so that is New Delhi. You can able to visualize the land subsidence, which is clearly highlighted in red color, high land subsidence. So pink color, which indicates very high land subsidence. And even in Andhra Pradesh, you can able to see here. So the pink which indicates the high level of land subsidence. So now let me navigate to my study region. So now let me close this. So using the inspector tool here, we can analyze my study region. So this is my study region. So this particular area has a very high level of land subsidence. So we're going to click this inspector tool on here, this particular, and we're going to visualize the details here. So we can able to visualize the land subsidence of around 10 centimeters, which is highlighted in Global Subsidence Classification B1 10, which indicates the 10 centimeter of land subsidence in this particular study region. So similarly, I'm going to click on red color and let us visualize it. So the land subsidence of around 5 centimeters observed in this particular study region, which is highlighted in the Global Subsidence Classification. So this is how we can able to estimate the land subsidence using inspector tool. So now I'm going to make another layer here. So we're going to clip the subsidence classification dataset based on our region of interest. So to do that, we define this variable called clipped subsidence classification equals to the subsidence classification dot clip basin boundary. So the basin boundary which represents our study region. So this is our study region, which is indicated in this basin boundary. And to add this layer, we define map.addLayer clipped subsidence classification. And these are the following color palettes in order to visualize the different classes of land subsidence. So starting from white to black, and we're gonna output the layer name as clipped subsidence classification. So once you did that, we're gonna navigate to this option called run and click run. And we're gonna navigate to the layer section, and I'm gonna turn on this particular the clipped subsidence classification. So the layer is getting loaded here. So now the layer appears in black. We're going to navigate to the layer section here, and we're going to click this option called the clip subsidence classification. And in that, I'm going to adjust this contrast. So I'm going to click stretch 90%. So now the value ranges from 1.9 to 9.1 centimeters of land subsidence. So I'm going to click apply. So now let me close this. So you can able to visualize here the black, which indicates a land subsidence of around 9.1 centimeters of land subsidence, and the white, which indicates the land subsidence of 1.9 centimeters. So the previous output that is our clipped subsidence probability. So it only shows the probability of land subsidence, that is the probability of land subsidence that have not occurred in the real world. But the clipped subsidence classification which shows the subsidence that have occurred in this study region. So there is a difference between the subsidence probability dataset and the subsidence classification dataset. The subsidence classification dataset, which shows us the occurred land subsidence, and the probability of the land subsidence, which indicates that may have occurred, not in the reality, but probability it can occur. But in case of subsidence classification, this particular data which indicates the land subsidence which have occurred in the real world. So for example, to visualize the difference between them, so we're going to use this particular tool called inspector tool. I'm going to click this inspector tool, and going to click this value here, and we're going to visualize the result here. So this is the global subsidence, this is clipped subsidence probability. So it is around 0.8959, which shows the probability that it can occur. And similarly, this is the actual subsidence that have occurred in this dataset, the clipped subsidence classification, which indicates the subsidence of around 10 centimeters. So now to export this particular image to a Google Drive, so we're gonna export this particular subsidence classification to a drive. So we're gonna define export.image to drive. So in the image, we're gonna define as a clipped subsidence classification. So that is this particular dataset here mentioned here, and description, the land subsidence classification, and the resolution. We're gonna set the resolution of this particular dataset around 100 meters, and the region of interest is our basin boundary dot geometry, which represents this particular study region. So this is our basin boundary. So we're gonna clip based on our basin boundary, and we're gonna set up a max pixel values and the coordinate reference system, and the folder where you'd like to export this image, that is land subsidence analysis. So we're gonna click this option called run, and now in the task section, we're gonna navigate to the task section here. So there is a unsubmitted task called land subsidence classification. To export this image, we're gonna click this option called run, and window pop-up saying initiate image export. So I've set the image to 100 meter resolution. So we can either export this image to your Google Drive or the cloud storage or your Earth Engine asset. So to export to my Google Drive, so I've selected drive option, and file name, and the file format is GeoTIFF. So to export this particular image to a Google Drive, I'm gonna define as run here. I'm gonna click this option called run. So once you click run, there is a option here that is a submitted task. So we're currently exporting this particular data set to our drive. So now we have managed to export this particular data set to our Google Drive. So you can able to visualize so the phase completed. So you can click this option to open in your drive and visualize the data. So in this video, I have shown you the land subsidence analysis using Global Land Subsidence dataset in Google Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like.